Sequencing Problem by Professor Sayed Jafar Sajjadi. Consider a part maker who has received an order to produce 3 products, A, B and C. And to produce these 3 products, 4 machines, 1, 2, 3 and 4 are needed. There are some sequences for production planning. For instance, the production of part A is first operated by machine 1 by a 1 hour, and then machine 3 by a 3 hour, and finally machine 4 by a 4 hour. Product B also needs to be machined, 1 by B 1 hour, machine 2 by B 2 hour, and finally B 4 hour by machine 4. Product C only needs machines 2 and 3. We need to build all 3 products, A, B and C, in minimum time. In other words, we want to deliver all 3 products in a minimum amount of time. We also assume there is a deadline for product B. We first define the decision variable, which has 2 indices, I and j. The index I is associated with products A, B and C, while the second index is related to different machines. J equals 1, 2, 3 and 4. Therefore, when XA1 is used, we mean the time that operations needed for product A are started on the first machine. The first set of constraints is associated with the sequence of operations. Product A needs machines 1, 3 and 4 in order, and each machinery needs a time. Therefore, we need to complete the operations on the first machine and then go for the operations of the third machine. We write 2 constraints for each sequence. For product B, we also need to consider the following 2 sets of sequencing constraints in order to make sure the operations of the first machine are completed before the second machine. Finally, for product C, the operations of the second machine should be completed before the third machine. The second set of constraints are considered in order to make sure one machine only handles the operation of one product at the same time. In other words, we first have to start the operations of product A on the first machine, and then start the operations of product B, or vice versa. Here we have 2 constraints that only one should hold in optimal solution. To handle this problem, we use a binary variable y and a big number m. When y equals 0, only the first constraint holds, but the right-hand side of the second constraint is added with a big number, and therefore the second constraint is not actually active in solution. Also, when y equals 1, the right-hand side of the first constraint is added by a big number, but the second constraint becomes active. We need to write similar constraints for machine 3 and use a binary variable to make sure there is no interruption for the operations of machine 3. Finally, we write 2 constraints for machine 4 and use a binary variable to make sure there is no interruption for the operations of machine 4. According to our assumption, we need to consider a deadline for delivery of product B, so the completion time of product B should be less than D. The primary objective of this problem formulation is to deliver all 3 products in a minimum amount of time. So we must minimize the maximum amount of time required for the 3 products A, B or C. Therefore, we are faced with a min-max objective function. In order to convert the min-max function, we assume z to be equal to one of the constraints. Therefore, z should be greater than equal to all of them, and we have the following. We hope this video would be useful for you and give a better understanding on the concept of integer programming. To learn how to solve such problems, we have prepared other videos. Please subscribe to our channel. Also, this presentation is a complimentary of the Growing Science publishing firm.